Okay, next up, this thing called named entity recognition that I mentioned is the thing that can tag words as whether they are associated with different types of thing. So here we have a sentence. Well, first of all, we're going to create our pipeline. The task is NER, named entity recognition. Device is CUDA. Once we've got our NER pipeline, we then can call it, and we'll call it with an input. AI engineers are learning about the amazing pipelines from Hugging Face in Google Colab from Ed Donner. Lots of entities in that. We'll iterate over the results and print each one of them. Let's run this. We get a bunch of warning-y stuff. Ignore it, ignore it. Look at that. I haven't even read what that is. It's obviously unhappy about something, but I don't care. Okay, so we got a bunch of these entities. Some of them are org, some of them are miscellaneous, and some of them are person. Okay, and let's see what they are. So they each are given an index. The first of them is AI, and the next is engineers. And then you'll see that Hugging Face got split up because it's doing it like token by token, which I guess we're going to come on to tokens in a bit, but you remember them from week one. So each token got tagged, but they are all done as a thing, Hugging Face, and Google Colab gets also done as a MISC. It doesn't know what that is, but Ed Donner gets a person. There I am. So it's correctly categorized the different things in this sentence and gives you an index into them. So that is the named entity recognition task. And there are a lot of business activities when it's important to be able to do this, to be able to pull out of a sentence what are the things that are being referred to. Next up is our nod towards RAG, our first time of doing something which is just a baby step towards the mighty RAG. It's about answering questions when you're given a bit of context. So supposing we have a question like, what are Hugging Face pipelines? And we've got some context, which is a bit more detail about it. Pipelines are a high-level API for inference of LLMs with common tasks. So we can then have a pipeline. We can make a pipeline that we'll call question answerer, which is good at answering questions. And the idea is you can always call it with a question and some context. And then we will print the result. So I'll just run that right away. And no doubt it will do a decent job of, there's its answer. Inference of LLMs with common tasks. They're pretty simple. Nothing, it's not rocket science, this one. But we are using, I think, quite small models. By the way, if it's taking a lot longer for you, that's because I already ran this. So I downloaded all the models already. When you run this, it's going to download the model each time. It's going to take a lot longer, as it did for me the first time. But I didn't want to be waiting around. So be comfortable with the fact that it will take a bit longer. But obviously, that time is only being spent building your pipeline. Once you've built it, you can run it quickly as often as you want. Same kind of performance as me. Just to tie the last two together, you might be saying, okay, well, that's very well, but the only way you'd be able to do that is if you were able to always provide relevant context that matches the question that's being asked. Well, here's a thought. You could run a named entity recognition on the question, and then for the entities that come back, you could look them up in your database to retrieve anything you have, any information. If it's a customer chatting with you about a different product, you could use named entity recognition to pluck out the name of the product they're asking about. And then you could just look that up in your database and put that in as the context and ask the question. You see, it all comes together. That's how you could use these different tasks. Now, of course, there is a better way and a more Gen AI way, and we'll be dealing with that in a couple of weeks, and it's called RAG. But this gives you some of the interesting building blocks that you can put into practice right away. And then the next two are just such standard Gen AI things. First of all, summarization. This is our pipeline. The task we pass in is summarization. We then have some text where I blathered away about the Hugging Face Transformers library. Incredibly versatile and powerful tool for blah, blah, blah. And then we ask it to summarize it. We give it some fields like maximum length and so on. And here we get back something nice and concise. The Hugging Face Transformers library, incredibly versatile and powerful tool for natural language processing. It's not that concise, but it's more concise than my waffle here. So there you go. That is summarization in a Hugging Face pipeline. And now translation. Translating, say, English to French. We'll use this pipeline, translation EN to FR. And here is a sentence. The data scientists were truly amazed by the power and simplicity of the Hugging Face pipeline API. and we will translate that. And for the French speakers in you can see whether you think this is any good. We'll see. It's thinking about that. Okay, I'm not. I'm not going to read it out. My high school level French is not going to survive your scrutiny. But there you go. That is the answer. Hopefully, that is acceptable. Now, you can also translate between other languages. And I put a link there to the Hugging Face models page already filtered on translations. And you can pick by language, you can filter on language, and then pick the model that will translate for you. There are some very specific languages. There's a big movement towards making translators for rarer languages, where this is something that could be like a language that's fading out, that people want to encourage and have people use it more. And it's really great that there are so many models for that. So stop talking and run this thing. We can also use this particular one to translate it into Espanol. And again, my hopeless level of Spanish is not yet as good with that as I am with LLMs, but hopefully this is a good translation you will be able to confirm. All right, so those are the two classic Gen AI use cases. And you might be thinking, hang on, Ed, I can just use ChatGPT for that, or I can just use the GPT API and do summarization and do translation. And of course you can, yes, but you have to pay for it, and you're doing trillions of calculations. This time we're using a much, much smaller open source model that has been optimized just for translation, or it's been fine-tuned just for translation, or just for summarization. And so you're able to do something basically for free, or, we're on a free box here, but if you wanted to do it at scale, you'd have to pay something. But it will be very cheap and very fast, and you have all the code and the weights. So by focusing on a task and using a small model that is specialized on that task, you can do more with less. You can get more accomplished at a very cheap price point and very fast. So that is the point. Let's move on. Classification is something where you can pass in a classifier. A zero-shot classifier means I'm not going to give you any examples. I'm just going to give you a sentence. I'm going to give you some buckets, and I'm going to say, put the sentence in a bucket. And so our sentence is Hugging Face's Transformers library is amazing. And the labels are technology, sports, or politics. Let's see what it says. It's going to put it in a bucket. It's going to give us some warnings first because it just loves doing that. And here we go. The labels, it's putting it in technology, sports, and politics. It gives it a 95% chance of being technology. It gives it a 3% chance of being sports, and it gives it a 1.8% chance of being politics. So there you have it. You should experiment with this and figure out what kinds of buckets, what works well. And you can also experiment with different models too, and see if anything can be absolutely confident that it is technology. Okay, and then the next one is the final text-related one is going to be a text generation. Obviously the main thing that LLMs do. If there's one thing I want you to remember about using Hugging Face pipelines, and now this is going to be using GPT-2 by default. GPT-2, remember that timeline? GPT-2 is from a bygone era, but it's kind of fun to do this because it gives you a little sense of what these models used to do with this. It's going to be super random, and I like to tell people that it's very similar. GPT-2 is very similar to like picking up your phone and just pressing the predictive text button again and again. If anything, it's even worse than that. Even predictive text is better than that now. If there's one thing I want you to remember about using Hugging Face pipelines, it's that you don't need to be a programmer to understand how they work. That's pretty good. The best way to learn about them is simply by using it for a few days. I can't disagree with that. However, there are some things you should do to learn the tools. You can use the following commands to add some features into your Hugo list. Now we're off. Now we're into some random territory. And basically, you can see all this stuff is now complete nonsense. Because remember, what LLMs are actually doing is just generating plausible text. They're not actually trained to give you the truth, just believable. They imitate the believable tokens. The fact that the bigger models are so often truth is something that is remarkable and somewhat surprising. But this is what you see when you use a smaller model, an early model. You see this kind of nonsense. It's the believable nonsense it starts to come up with. This means you can use any tool, such as Hugging Face's own plugin, for example. I love the way it's so earnest with its like parentheses, but complete drivel. So there you have it. That is text generation using the default model GPT-2 from back in the day.